Welcome to The Explainer. Today, we're pulling back the curtain on one of the most exciting fields in tech, how modern AI applications are actually engineered. From just an idea all the way to a global service that anyone can use.
And we're going to start with this really powerful idea from AI expert Chip Huyen. The game has totally changed. Building with AI, it's no longer locked away for a few specialists in a lab. It's becoming a fundamental tool for pretty much all developers and creators out there. So here's how we're going to tackle this. Think of it like an hourglass. We'll start broad with the big picture, then we'll narrow down to the nitty-gritty building blocks, and then we'll expand right back out to see how it all clicks together in the real world, and of course, what it all means for you. Right, so what exactly is this new frontier? Well, people are calling it AI engineering. And it's a huge shift in thinking, really. We're moving away from treating AI as just a research problem and starting to treat it like a structured, scalable engineering discipline. And listen, this isn't just hype. I mean, if you look at the numbers, the tools used to build AI are just exploding in popularity. We're talking about open source AI tools getting more attention on places like GitHub than even legendary projects like Bitcoin or the web framework React did. That is a massive signal of where the entire industry is headed. Okay, let's get into the core concepts. Because to really get how we build these things, we have to start with a pretty basic question. How does an AI model actually, understand human language? It all starts with this little thing called a token. The best way to think about tokens is like they're the Lego bricks of language. So before a model can process a sentence, it has to break it down into these smaller pieces. This lets the model handle a huge vocabulary, and even words it's never officially seen before. And this visual here shows the next logical step perfectly. The model starts to learn the relationships between all these tokens. It figures out that words like park and play are really close in meaning, while words like park and car, well, they're related, but in a totally different way. It assigns these weightings to map it all out. And this is where embeddings come into the picture. To actually do all this math, the tokens get converted into these numerical vists or vectors called embeddings. An embedding is basically a mathematical fingerprint for a word. It captures all of its rich meaning and context as just a series of numbers. So here's the absolute key takeaway. By turning language into numbers, we can use math, specifically linear algebra, to process meaning. That's it. That's the engine room. This is fundamentally how these models think and come up with their responses. Okay, so we've got the concepts down, tokens and embeddings. But how do we get from these abstract building blocks to an actual app that you and I can use on our phones? Let's walk through that. The journey from just an idea to a full-blown AI application isn't some kind of mysterious magical event. It's actually a very disciplined, repeatable engineering workflow, pretty similar to how any other professional software gets built. You can really break this journey down into 5 key chapters. It all starts on a single developer's computer where they set everything up and do the initial tests. Then it gets packaged up so it can run anywhere, gets pushed out to a live cloud server, and finally, it's watched constantly to make sure it's running smoothly. This whole process here is often automated in something called a CI/CD pipeline. That stands for continuous integration and continuous deployment. We use tools like Git to track every single change to the code, and then a tool called Docker to containerize the app. A container is kind of like a standardized shipping box that holds the app and everything it needs to run, which guarantees it'll work the same way everywhere. Now, getting a simple demo to run is one thing, but building a professional, production-grade application that millions of people might end up relying on, well, that's a whole other level of discipline. A student project, for example, might get tested by hand and only ever run on one person's laptop. But a real-world production app? It needs automated testing, constant monitoring in the cloud, and a build process that is perfectly repeatable and versioned. You have to know exactly what code is running at any given moment. Reproducibility is everything. And this is exactly where the discipline of MLOps, or machine learning operations, comes in. It's really a philosophy and a set of best practices that are borrowed from the world of software development, but they're specifically tailored for the unique challenges of machine learning. It's all about making the entire AI lifecycle strong,
automatic, and efficient. And what's really cool is this rich ecosystem of tools that has just popped up around MLOps. So on one end of the spectrum, you've got open source platforms like MLflow, which acts almost like a lab diary for tracking all your experiments. And on the other end, you've got these massive enterprise-grade platforms like Google's Vertex AI, which is built to handle the entire lifecycle at an industrial scale. So, with all this talk of pipelines, containers, and MLOps, why does any of this actually matter to you? Well, because understanding this whole process isn't really optional anymore. It's becoming the key to unlocking a future in tech. The skills we've just walked through, handling data, using these powerful pre-trained models, deploying to the cloud, packaging apps with Docker, building those automated pipelines, these are precisely the skills that companies are desperately looking for right now. And this whole shift is creating entirely new jobs that just didn't exist a few years ago. We're talking about roles like an AI integration specialist who connects models to business systems, or a cognitive systems trainer who helps fine-tune a model's behavior, and of course the prompt engineer, who's an expert at crafting the perfect instructions to get amazing results from an AI. Look, at the end of the day, the tools to build, test, and deploy incredibly powerful AI are becoming more accessible every single day. The barrier to entry is just dropping like a rock, so the frontier is wide open, really, empowering anyone with a great idea and the discipline to follow the process. The only real question left is, what are you going to build with it?